Okay, so we have this calculus problem we have to do, and it involves sketching a graph. And what we're going to do is use the domain, symmetry, intercepts, asymptotes, relative extrema, and any points of inflection. And we also have to identify the open intervals in which the function is increasing or decreasing, and it's also its concavity. So first, let's start out with what the function is. We have f of x equals x cubed plus 2x squared minus 4x minus 8. And we know for a polynomial like this, its domain is going to be all reals. So we have the domain going from negative infinity to infinity. So there's no issues here, because it's not a rational function. So first things first, let's begin with the symmetry. For x-axis symmetry, I plug in a negative for y, and we see if anything happens if we return to the original function. Obviously, we can see right off the bat, this is not going to work. So now we can try for the y-axis symmetry and put a negative x for all the x's, and we'll see that we're not going to get back to our original function, so it also does not have y-axis symmetry. Now let's try for the origin symmetry. We'll put in a negative y, and then we'll have a negative x. We'll get something close to it. You can do it out yourself, and you might get something very close, but it's not going to work at all. So no symmetry for this function. So what we want to do now is find the intercepts. Here I'm starting with the y-intercept. I plug in 0 for x, and what results is y equals negative 8. So at 0, negative 8, we have a y-intercept. Now I want to find any x-intercepts. So for this function, I'll do some quick grouping, and what results is x squared minus 4 times x plus 2, and set that equal to 0, and we'll get x equals plus or minus 2, because you'll just bring that 4 over, you'll get square root of 4, which is plus or minus 2, and this is just going to give us the same thing. So that's the first part, and now we're going to jump into the second part for this function, sketching it. It's a long problem, bear with me, it's going to be a little tedious. Okay, so we're back to the problem now. We want to look at if there's any asymptotes. Being that it's a polynomial like this, it doesn't have any asymptotes. If it was a rational function, it'd probably be a different story. So now what I want to do is find where this function is increasing and decreasing. So what we need to do is first get the derivative of this. So taking the derivative, we get f prime of x equals 3x squared plus 4x minus 4. Doing some quick factoring, we can get this to be 3x minus 2, and then times x plus 2. I'll set this equal to 0, and I'll get some points on the graph here. So I have negative 2 and then 2/3. So now I want to find out where it's increasing and decreasing. So what I'll do is I'll section everything off and see what's happening from negative infinity to negative 2. I'll use negative 3, which I'll plug into the derivative of this f of x function. So I'll put a negative 3 in for x, and what results is negative times a negative, which will be positive, so we get a positive number, so it's greater than 0. Thus, it's increasing from negative infinity to negative 2. Now I want to see what's happening from negative 2 to 2/3. So I'll keep it simple. I'll use 0. Put 0 here. We get a negative 2 times a positive 2, and what results is a negative number. So it's decreasing from negative 2 to 2/3. Now to see what's happening from 2/3 to infinity, I'll use 2. We plug in 2 for x. We're going to get a positive number, and then we're going to get another positive number. So it'll be increasing from 2/3 to infinity, as shown by the arrows. So what we can acknowledge now is that we have a relative max at x equals -2, and we have a relative minimum at x equals 2/3. And in the next part, we'll do some more with this, and we'll get the exact points for this. Okay, we're back again. So, as we found out in the last part, we know that it's increasing from -infinity to -2, and then from 2/3 to infinity, and it's decreasing from -2/3 to -2, sorry, to 2/3. So now what we have to do is we have to find the second derivative, so we can find the concavity, where the concavity is on this graph, and how it functions. So we have f prime of x equals 3x squared plus 4x minus 4. Take the second derivative, we get 6x plus 4. I set that equal to 0, and we end up with x equals -2/3. And we have this graph here that I'm going to find the concavity. So we know from -infinity to -2/3, if I put -1, which will be on this other side, I'll have a number that is less than 0. So I know that it's going to be concave down. And you can check these by putting them into the second derivative here, and you'll see you'll get a negative number. Now I want to see what's going on this side from -2/3 to infinity. So I'll keep it simple, use a 0, and I plug in 0, I'll get a positive number, so I know it's concave up because it's greater than 0. So here we go, it's concave up. And being that we have concave down here and concave up here, I know I have a point of inflection at -2/3. So at x equals -2/3, there's a point of inflection. So what I'll do is I'll take my original function and I'll plug in -2/3 for x. So then we'll have -2/3 cubed plus 2 times -2/3 squared minus 4 times -2/3 minus 8. So what we end up with is -8/27 plus 8/9 plus 8/3 minus 8. So do some algebra. What results is -128/27. So at -2/3 and then the -128/27, we have that point of inflection. And now that we got all this done, we'll be able to actually sketch the graph and be done with this long problem. As I said before, it's pretty tedious. Okay, so we finally have all the information we need for the function of f of x equals x cubed plus 2x squared minus 4x minus 8. So we know there's no symmetry, and we know the domain is from -infinity to infinity because it's a polynomial. We know there's no asymptotes. We know we have an x-intercept at -2, 0 and 2, 0. We also have a y-intercept at 0, -8. And we know it's increasing from -infinity to -2, and then from 2/3 to infinity. We know it's decreasing from -2 to 2/3. We know we have a relative max at -2, 0. And we also know we have a relative min at 2/3 and then -256/27. And we know it's going to have a concavity that's down from -infinity to -2/3. And it's going to be concave up from -2/3 to infinity. And we also have a point of inflection at x equals -2/3, which is the point -2/3 and then -128/27. And now I can finally show you the graph. So here we have the graph for this function. And I'll run through everything that's happening here so it can match up with yours. So from -infinity to -2, we are increasing with it being concave down. Then we see from -2 to -2/3, it's concave down again, and it's decreasing. And then from this point here to this point down here, it's concave up and still decreasing. And you notice here we have a point of inflection because we're going from concave down to concave up. And we pass through our y-intercept here. And you see that from this point here to 2, we now are increasing and we are concave up still. And we go from here to positive infinity. You see it's concave up and increasing. And we have our relative min here at this point, and over here is our relative max. And we have our x-intercepts at -2 here and at 2. And that pretty much sets us up for the graph, and it should match up with yours.